Hey everyone, welcome to this video series called Textbook to Code, where I take computer science and software engineering textbooks and sort of expand on them and convert them to code and discuss them, kind of like what one would do in a tutorial in university. Now, if you're new to this channel, I generally make videos on philosophy, but I realized my other great love, other than philosophy, is computer science and software engineering. So I was thinking, why not do the same thing with that field too? And as the title suggests, the first book I'll be covering is Effective Java by Joshua Bloch. Certainly the best Java book I've read, even though I'm still trying to grok certain concepts on it. It was recommended to me by my CTO at my current company, and he's been a Java programmer for, I don't know, ever since the internet. That was a joke, by the way. I know Java was created after the internet. He's been a Java programmer for a long time, and he said that this was a really good book to read. Not really for beginners, but more for intermediate Java developers. I consider myself still a beginner to intermediate, so I don't really know at what level one should get into this book. However, I do believe really the way it's structured, anyone can jump into it if you have a basic understanding of programming. So Effective Java contains about, I believe, 90 items, which means this video series will encompass 90 items. And afterwards, I'm hoping to get to this book, which probably is going to be next year because it takes a long time to make these videos. The Head First Design Patterns by O'Reilly, which I've just started on, and it's brilliant. I'm so grateful for all these authors who just take so much time to educate and help upcoming burning software engineers like myself, who generally aren't the most intelligent programming whizzes out there. Saying that though, as per usual with my normal videos, if you do follow this channel, you know that I tend to make a lot of provisos or caveats. And the first proviso is, this is not a tutorial. And that's really important because the last thing I want to do is to propagate false information or teach something that's wrong. And, to make this a video series of misinformation, to use a very politically loaded term. I'm not a teacher, not an expert. I've only been a Java programmer, really hands-on, for about 2 years. I'm still learning myself. I'd like to think of this video series and all the videos in this channel, as a matter of fact, as more of a blind leading the blind kind of experiment, let's say, where I am also naive and ignorant about these topics. So it's just more of a exploratory disquisition, let's say. Yeah, I'm just trying to see what this particular concept is. I'm trying to break that down, which means I will inevitably make mistakes. No question about it. So please point them out. Leave those out in the comment section below. I'm sure there are much more advanced, competent Java programmers who will point out some of my flaws. And when I say blind leading the blind, I don't mean I'm leading anyone else in that sense. The point I'm trying to make is that let's try to collectively work on this. And again, the best example I can use, or the best analogy I can use, is what one would typically do in a university tutorial where we work with the tutor and the other students to solve a particular problem. And of course, since this is a programming video, engineering video, all the code that I use to expand on the first item, I shall have it on my GitHub account. I'll leave a link down below. You could go download it and play around with it yourself. On that note, let's jump into it. We'll start with item 1. So this is from chapter 2, Creating and Destroying Objects. I'm not going to cover chapter 1 because it's essentially just an introduction. And the same way that I give caveats in this video, Joshua Bloch himself gives a few caveats on what this book is about. Just for context, Joshua Bloch is brilliant. He was, I think he created, or he was a big part of the Java collections framework. He's a distinguished engineer at Google, I believe. So he's been a part of the Java JVM community for a long time. And I certainly look up to him, and I really enjoy just even watching some of his talks on YouTube. But this book really opened my mind into the power of the Java language, and in fact, OOP principles in general. So again, as I said, chapter 2 is Creating and Destroying Objects. And the first item we're going to cover is, let me zoom in a bit because I don't want this to not be visible. The first item we're going to cover is consider static factory methods instead of constructors. So when I read this item, the first time I read this chapter, this item, my question was, what is a static factory method? And in simple, the very textbook answer would be, it's a static method that returns an instance of a class. Now, don't worry, I've got the code base right here. We're going to jump into all of these things in much more detail a bit later, but I think it's sort of important at a high level to get the terms right and get them all in order, just to help our thinking. Look, I'm just going to say my thinking. I'm not going to pretend as if this is a collective thing. It's initially me making a video, and then eventually, hopefully, it can be a collective thing in the comment section down below. And, nota bene, this is not the same as the factory method design pattern. Even though, I'm not going to lie, maybe this is my lack of understanding of the design pattern. I see many similarities between what the static factory method does and then the design pattern. So perhaps that's why it's called a static factory method. So let's take a look at the keywords, first of all. So when we say a static factory method, and let me show you a quick example, in fact. So here we have the big integer class, and a static factory method here would be that right there, public static big integer. The probable prime method, for instance, is a static factory method. Which means we got a question that I asked myself was, what is static? And I took down a few notes. Of course, the word static means a lot in software engineering. And my notes said that the word static ensures that a member belongs to a specific class. So again, in the example of this big integer class, this member as in this method belongs to this specific class. Therefore, only one instance of the member exists, regardless of the number of objects of the class created. So it doesn't matter how many instances of the big integer class is created, but there's only going to be one instance of this method, because this method, the probable prime method, belongs to this big integer class. There won't be multiple objects of that being created. And a static member is shared amongst all objects. So because it belongs to a certain class, any other, let's say, client that uses this class and creates an instance of this class with the new keyword just shares that specific object. Pardon me, not really the object. I think I misspoke there. More the static member. I think it's better to think of it that way. So, of course, I'll get into all of this stuff in detail a bit later. So, of course, that means that when you want to use this method, the probable prime method, one doesn't have to create an object of the class, use the new keyword the way it's done in Java. It just makes things easier. Also, and another caveat here, my understanding of Java memory management is very, very high level. I know it's a very deep topic. It goes all the way into the depth of what computer science is and engineering in general. So I have a very, very superficial understanding of it. But my understanding is that static content, so it could be a class, a variable, a method, doesn't matter, will be stored in a place called the dynamic metaspace. So the JVM will store it in a place called the dynamic metaspace, which I've learned replace something called the permanent generation since Java 8. So all these static members live in the dynamic metaspace. Now, this is an important point that we're going to get to in this video. I've got a whole bunch of resources and study material that I used as I was creating this video and studying this book. So for each item, all the supplementary reading material and studying resources, which I have a whole list here, just articles, blog posts, videos, whatnot. I shall leave them down below in the description. I really think it's super useful, along with the book, along with each item. Reading those supplementary articles, it gives, at least for myself, it gave a really good understanding of what Joshua Bloch is talking about in each item, especially given that he expects the readers of this book to be quite proficient in Java. So if you're sort of in an intermediary level like me, these background articles help. And on Java memory management, a very grokkable, easy to understand video that I watched was by Naveen Automation Labs. I thought he explained it quite well. He's a great pedagogy, great teacher. It made a lot of sense to me. And then I read this article about what the metaspace is in particular, because since we're talking about the keyword static. So along with the word static, the other sort of keyword of these methods is factory. And here's where I said before, it seems a bit similar to the factory method design pattern. And maybe it's because it does follow certain aspects of the creational design pattern, even though there's no direct relation. In fact, in the book, it says here, it says here, note that a static factory method is not the same as the factory method pattern from design patterns. I feel terrible now. When I looked at the book, I realized that I've highlighted certain things, as you can see. These bits from the book I wanted to read out, and I didn't do it in the beginning of this item. So I'm going to do that right now. I'm so sorry if this is chaotic and a bit messy. Please forgive me. I'm still trying to figure out how all of this works and how to expound on these matters. So I'm going to read this is a mess. I'm so sorry. I'm going to read the introduction to the item now, which I was supposed to do in the beginning of the video, but I only realized that now. So here's what Joshua Bloch says. The traditional way for a class to allow a client to obtain an instance is to provide a public constructor. There's another technique that should be a part of every programmer's toolkit. A class can provide a public static factory method. There we go. Which is simply a static method that returns an instance of the class. I'm glad I read that, because I should have started with that bit, because it's too confusing if not. Anyway, getting back to the factory keyword. So what this also does is it allows to encapsulate the object creation process, because if you do notice, and we'll get into this again, the constructors are private. So clients cannot access the constructors and create objects as they wish. In many ways, is in fact one of the advantages, which we'll get to again later, of using static factory methods. The class can decide when to create new instances of the class, and it's not that a new object is created for every invocation when a competition is required. So therefore, I don't know if this makes sense, but I think it's because it resembles certain creational design pattern, let's say, elements. The word factory is used to describe them. So now let's get to the why, the advantages. What's the justification? Why is Joshua Bloch telling us to use static factory methods instead of constructors, how one would typically do? The first one Joshua Bloch talks about is that, unlike constructors, static factory methods have names. They tell to the client, or they indicate to the client what this method's doing. The example he's used is in the big integer class. Now he said here, the constructor, which is this, which I've taken down here. So in fact, maybe I should go to the code itself without just showing it off Notion. If you go to the big integer class, here we have the, all right, found it, sorry. It's a really big class, so I had to go through the code. The constructor here, which is the constructor for the big integer class. In fact, on the comments, it even says here, constructs a randomly generated positive big integer. There's probably a prime with the specified bit length, but it also says here, it is recommended that the probable prime method is used in preference to this constructor unless there is a compelling need to specify a certainty. Correct. So what this does is it just returns a big integer, which could be a probable prime. But this is just a constructor. It's just the name of the class. It doesn't really, to me as a client using this, doesn't tell me what this does, which is why it's better using the static factory method, the public static big integer probable prime. Can't pronounce that word. Right there, where when me, a client, is using it as I've used it right here, I clearly know what this method is doing. It makes the code clean. And of course, a class can only have a single constructor with a given signature. You can't have, at least in Java, I don't know about other programming languages, but I don't think so. One can't have multiple constructors for a class. I assume. Maybe I'm wrong there. That's at least my understanding. And then a very basic question to ask is, what's the purpose of a constructor? The purpose of a constructor really is, as the name suggests, to construct a class. As it's said in the Oracle docs, a constructor is used in the creation of an object that is an instance of a class. Typically, it performs operations required to, I'll zoom in a bit. Typically, it performs operations required to initialize the class before methods are invoked or fields are accessed. Constructors are never inherited. So, for me at least, as a client, using the probable prime method makes more sense. He says, because a class can only have a single constructor with a given signature, programmers have been known to get around this restriction by providing two constructors whose parameters, whose parameter lists differ only in the order of their parameter types, so method overloading. This is a really bad idea. The use of such an API will never be able to remember which constructor is which, and will end up calling the wrong one by mistake. People reading code that uses these constructors will know what the code does without referring to the class documentation. Because they have names, as in static factory methods, we don't have this restriction. And when I was reading this paragraph, I had a bit of a grin, because in the project that I'm currently working on, which is a huge enterprise, massive Java project, I think we've got 40 odd microservices. And I see this happen all the time. We've, a lot of legacy code. We've done a lot of method overloading. And sometimes when as a client, I'm using a certain class, or even if I'm instantiating a class, I'm not even sure which parameters to pass into the method, because it's been overloaded so much that it's hard to work on as a client. Whereas with the big integer class, I exactly know what I'm doing here, just using the probable prime method. So the second justification or advantage is that static factory methods, as I've sort of said many times already, do not require object creation each time they're invoked. It's one of the biggest advantages, in my opinion. This allows immutable classes for sure. It's also similar to the flyweight design pattern. Now, I put this note here just because I want to kind of put into the notes everything that's in the book. I have no idea at the moment what the flyweight design pattern is. I haven't done any further study into that. So hopefully when I do, I'll probably revisit this and leave a comment explaining what it is from my point of view. The example that we can use here is, in fact, this little method that I created. It's an example from the book, which was this method right here. It's this simple method that I created called value of. It's an example from the book. So if I want to use this method, and this method is in this class called manipulate strings, I don't have to create an instance of the class. Let me demonstrate. So for instance, if I go here, and if I want to print out something, let's just say value of, and we go manipulate strings dot value of. I'm going to pass a true there, and then I run that. You will see it'll just print true. Again, sort of a useless method. And as you saw there, I didn't use a new keyword. There were no objects being created. I simply accessed the method via the class, because that method's owned by that class, so to speak. Then another advantage of not having to create objects is, And it took me a while to grok this concept because I had to do a bit of stack overflowing, to use a term that we all love as software engineers. It makes classes instance controlled. So it says here in the book, the ability of static factory methods to return the same object from repeated invocations allow classes to maintain strict control over what instances exist at any time. Let's try and understand this. So firstly, just keep in mind this makes a class singleton and non-instantiable. So essentially singleton means at a given time only one object of that class can exist, whatever the class may be, if we follow that pattern. And I really only understood this thanks to Joachim Sao, who posted a really good answer on Stack Overflow. I shall leave a link to this down below of what this concept means and how using static factory methods makes classes singleton and immutable. So to get this concept first, let's see what Joshua Bloch is saying. He's saying that, yeah, it allows immutable value classes, as I repeated multiple times already. And then it says to make the guarantee that no two equal instances exist, as in A equals B. So class A equals B only if it's equal in this sense, as in this equals sign means that the values in the objects are compared. The double equal sign is a reference or a memory location of objects in the heap. So as I said, thanks to Joachim Sao, I think I got what this meant. It gives complete control to the class as to when instances of this class will be created. Now here's the example that he's used. So I did have it here. I'll zoom into that. One of the methods here is deprecated, so you can't, clearly, as you can see here in the docs, it says that it's marked for removal because we don't really create new instances of the Boolean class anymore. Now, I'm going to comment that out for now. You'll see here, if I print this, we're getting a true and false. Despite the first one, because we're looking at the value in the object, we're getting a true. But here in the reference comparison, or in the memory, we're getting a false. Now, personally for me, this was okay. I got what he meant conceptually, but really what I did was this. I created another small class called Fuba. As you can see, I made the constructor private, so it's inaccessible to any client. And then what I did was I created a static factory method called construct Fuba. If you can clearly see here, what I'm doing is I'm returning a new instance of the Fuba class. But in the method body, I have an if condition, and I say only if the number is greater than 5, is it allowed to create a new instance of this class. Now, yes, one could say you could do this in a constructor too, but doing it in a static factory method makes more sense due to the previous advantage we spoke about, the fact that we can use the name in the method. So you'll probably see here, I'm going to comment this out again. Now, I'm using the construct Fuba method, and initially I'm passing the number 7. And then if I run that, it's, if I zoom in here, there you go. That's the object that was passed through. So it returned a new object of the Fuba class. But that's because 7 is greater than 5. But if I pass 2, it's a null. So this is what Joshua Bloch means by it gives classes complete control as to when instances of that class will be created. On that point, I would also say just to keep in mind that enum types provide this guarantee, by the way. So if you do this comparison that I did before between different classes or between different types, you'd see it follows a pattern with enum types. The third point is, or the third justification, or why, so to speak, is unlike constructors, static factory methods can return an object of any subtype of their return type. This again, a bit like the instance control bit, it took a bit of time for me to understand what it meant. So let's see what we mean here. The best example to use is certainly my favorite Java framework, the collections framework, is to demonstrate what an interface-based framework is. So the first thing you'll notice is, if you go to the collections framework the class, sorry, if you go to the public class collections, its constructor is private. So you can't instantiate it. And then if we take a look at this little bit of code that I put in, I'm creating a array list. I'm creating, in fact, two array lists, a source and target list of string type, and I'm adding values into it. And then in the collections class, I'm using this static factory method right here. And what that does is it returns, let me just read the documentation. It's much easier because they put it in much better terms with brevity. Returns the starting position of the last occurrence of the specified target list within the specified source list, or a -1 if there is no such occurrence. So here we have the source list, here we have the target list, and what I'm trying to see is I'm trying to find the first occurrence of this value of the target list in this case. So as you can see, this CDE, which is the, let's call it the sub list for the all intents and purposes, it starts at the index number 2, 0, 1, 2. And if you print that out, it returns that here. Now, that's besides the point. But the important point here for over here is that the collections class is returning a type of index of integer. It's returning a subtype, as it says here, is that unlike constructors, they can return an object of any subtype of their return type. So it's returning an integer subtype, which is different to the type of the collections class. And then, of course, he expounds on the matter. He says, this technique lends itself to interface-based frameworks, where interfaces provide natural return types for static factory methods. And of course, a good example of that is the collections framework. This class itself, just going through it, would prove that. Then he says, prior to Java 8, interfaces couldn't have static methods. By convention, static factory methods for an interface named type were put in a non-instantiable companion class named types. So these kind of methods had to be moved to a separate class. And then, as I said, he says, for example, the Java collections framework has 45 utility implementations of its interfaces, providing unmodifiable collections, synchronized collections, and the like. Nearly all of these implementations are exported via static factory methods in one non-instantiable class, namely this right here, Java utils.collections. Furthermore, using such a static factory method requires the client, which is me in this case, to refer to the returned object by interface. That's what I'm doing right here. Interface rather than the implementation class, which is generally good practice. The fourth advantage is that the class of the return object can vary from call to call as a function of the input parameters. Now, the example he's used in the book is that in the enum set class. So let's take a look at that. What I've done here is by the way, the example I've used is thanks to Bill Dung. Now, I know that every Java developer out there uses this website as reference, but I know that all of us struggle to pronounce this word right here. I think it's pronounced Bill Dung. It's the best outside of the Java Oracle docs itself. It's, in my opinion, the best resource out there. So courtesy of Bill Dung for this example. So to get back to this, what does Joshua Bloch mean by the return object or the class or the type of the return object can vary from call to call depending on the input of the function? So I'm using the static factory method none of here, which is a part of the enum set class. And I'm passing a enum into it, which is this enum I created called color, which just contains about a bunch of colors. And then it returns a enum set. Now, what changes here? So what changes here really is this. In this method, you could probably see it extends to generic. That's fine. Well, not that's fine. It has to be a generic because the types have to differ. So of course, if it's null, it'll throw a class exception. However, you see this, the returning object. There are two types of objects that are being returned here. If the length of the enum pass, so the enum that I'm passing colors here, if the length of this is greater than or equal to, less than or equal to 64, it'll pass a new instance or a new object of the regular enum set class. So if I run this code now, you'll probably see here, I'm printing out the class name of the return enum set. The class name is regular enum set. It's in fact a subclass, pardon me, or a subtype to be more accurate. If you look here clearly, it's of a different type. It's not the type of enum set. Now, what happens here though is if the passed enum is greater than 64, it returns a different type called a jumbo enum set. So it's this flexibility that using a static factory method gives us. So to reiterate, depending on what the input is to this method, a different type can be returned. It'll vary purely based on the input. And then Joshua Bloch says that clients neither know nor care about the class of the object they get back from the factory. They care that only it is some subclass of the enum set. Correct. As far as I'm concerned, when I was using the none of method, all I wanted it to be was of the type enum set. I didn't care what subtype it was or what subclass it was. And that moves to the final justification as to why one should use static factory methods as per reasoned by Joshua Bloch. And I gotta say, if you can already see from this video, I'm even struggling a bit to explain myself and properly articulate my understanding of these concepts. Perhaps that's my own lack of communication, lack of the ability to articulate myself, but also it's because I'm still dealing with these issues and trying to make sense of it in my own mind. This one right here, the fifth point, it took me about a week to write the script. The fifth point, I spent 4 days on it because it did take a bit of understanding of the JDBC framework to see what Joshua Bloch is talking about here. The fifth point he tries to make is that the class of the return object need not exist when the class containing the method is written. So let me reread that. The class of the return object, whatever the method invocation returns, need not exist when the class containing the method is written. Now, firstly, he says such flexible static factory methods form the basis of service provider frameworks. Now, I was a bit embarrassed because I've used JDBC quite a lot, but I didn't know that it was a service provider framework. I didn't know that that's what it was called until I read this book. And it's kind of funny how, by the way, I just want to make this point here. The great thing about reading such books is that all these different libraries, like all the frameworks, like the collections framework or JDBC API, that we use in our day-to-day job that we really don't think too much about, we start really appreciating the engineering and the kind of the craft of them once we understand the reasoning and the principles behind how they were built. So this is a good example of how JDBC is a sorry, my mind threw a blank there. A service provider framework. So I found it a bit hard to understand the point Joshua Bloch's making using the JDBC framework. However, just to get the ideas of what it is, I put together this bit of code here. And as I read before, it's got the provider registration and the service interface. So in this line of code here, the driver manager, the register driver, this bit here is the provider registration. And driver is the service provider interface. And then if you go here to connection, again, connection is the service interface, and driver manager dot get connection is the service access API. So essentially what I'm trying to demonstrate here is the different components of what a service provider framework encompasses. And as you clearly saw, I did a terrible job at explaining how this relates to our item in using static factory methods, which is why I found a much simpler example on Stack Overflow where we have this right here. This was by Bruno Reyes, and I thought he explained it much better. So he says here, with this code, your library doesn't need to know about the implementations of the service. Users of your library would have to set a system property containing the name of the implementation they want to use. which is if we go down here, this static factor method here, which is stored in this class, will just give us a new instance. As in, I don't care if this class was created or if it exists or not. All I'm expecting is because I'm getting it through the contract between the interface, that I'm getting a instance of the my service class. That's it. Gosh, I think I butchered that. So again, to reiterate, this static factor method for name is going to provide an instance of some class, which is the class right here. In this case, it's the driver class. And that's all I care about. I just wanted to come of this type. I'm doing a typecast here. And that's all I really care about. And that's because of this contract that I have with the interface, essentially. Okay, this is why I said that this isn't a tutorial, because that fifth item is something that I'm still struggling with. And I swear, I tried to make sense of it through the JDBC framework, but it was a bit hard for me to really grok. And then I found this answer on Stack Overflow, which I thought was done much better. But look, if any of you know a better way of explaining it, please do leave it down in the comment section. I would be very grateful for that, because that's certainly one advantage from this item that still I don't still fully get. So having discussed all the advantages or justifications apropos using static factor methods, let's now get to the limitations. The limitations aren't really much, so it makes a lot of sense to use them in most places, unless there's an exception, let's say. The first one is that classes cannot be subclass without public or protected constructors. On the note, just before I get to demonstrating what this means, there's a good resource, sort of, I guess, an answer on Stack Overflow that I found, which discusses why constructors are needed for subclassing. And I thought it was quite good. So I'll leave a link to this in the description down below too, if you want to go give it a read. But simply, it's very easy to show. So here I have a class called main, and then I have one class, which is another class called animal with constructor. So if I go to that right here, we have the public class, and we have a public constructor, as you can see here. Now I can easily go to the main class, and type extends animal there we go, and it simply extends that class. However, now I have another class without a constructor. In fact, I've made the constructor private, so it's not accessible by the subclasses. And if this tries to extend this, an error is thrown. It says here there is no default constructor available in the superclass. So, and also if I try to create an instance of this, we get the same error. Now, what's funny here though is, of course, Joshua Bloch says, and I'll read this out. Arguably, this can be a blessing in disguise because it encourages programmers to use composition instead of inheritance. Exactly. I don't have to extend that class. I can use one of the most fundamental OOP design principles to try and favor composition over inheritance. The second limitation is that he states, I don't even really know what he means here, that it's hard for programmers to find, that these methods are hard to allocate. I'm not sure if that really applies anymore, because for instance, I use IntelliJ with really powerful exhaustive IDEs like IntelliJ. All I got to do is hit command and click on the method and boom, I'm there. I've got the docs, everything I need. So I wouldn't say it's hard for programmers to find. Nevertheless, he does state that, so I'm sure there's a good reason for it. And then what he says is, because some of these static factor methods are hard for them to find, that he's gonna enumerate a few of them and list down some commonly used static factor methods. So I thought I'd do the same. And once again, all of this code is gonna be on GitHub. So if you wanna take a look at some of these methods, just click the link down below and you'll have access to it. So the first one is a from method, which does essentially a type conversion method. So it's quite easy to understand, really. What we have here is we have a type of instance, and we pass it to the date, and from that instance we get a type of date. So it does a type conversion. If I run that code, you'll see that that instance type was converted to a date type, and then it printed it down here. The second one is a aggregation method. What this does is similar to a previous example that I used, is it takes this enum list. So I've got a enum called rank here, Jack, Queen, King, and then it just gives us a set, an enum set of this enum right here. So if I do print that out, you can see here it's printing that set on the face card. So it makes sense to call it an aggregation method, because what it does is it takes all these different items in an enum class and then aggregates them and returns a type of enum set. And then we have the big integer value of, which again, this is the same thing. It's a type conversion method. And he says, yeah, it's a verbose alternative to from and of. So in this example, you could probably see I'm passing into this method something of type integer, and it returns something of type big integer. So just that type conversion there. The next example is, it's sort of like I've created a quasi demo for this get instance methods. Essentially what it does is that it's described, it returns an instance that is described by its parameters, if any, but cannot be said to have the same value. So the example here would be, I've got this void method called method3, and this StackWalker class here is getting an instance of the class that invocates this method. So this is in the StackWalker demo class. And as you can see, if I go up here, there's an instance. Oh, that was a mistake. I should have made that a static method. I don't know why let me correct that right now. Public static. That is good, because it shouldn't be a... Sorry, that was a confusion. The actual static factory method was this. In the StackWalker class, the get instance class. This is what happens when I work on these things way back and I record the video on a separate day. Sometimes even I forget why I did what I did. But just to get back to this, so I've created the StackWalker demo class, and I've created an instance of it right here, which is boom. And I'm accessing this method through the object or the instance of that class. And what this does really is it just prints out the caller class. So the StackWalker.getInstance, as you can see here, it gives us a reference to the class that invoked this method. So method 3 was invoked by this class here, the common static factory methods class. So if I print this out, you'll see here, it tells us, this was the class that invoked this method. And it's using the getInstance static factory method. And the next example is quite similar. The new instance method will guarantee that every invocation of it will return a instance of the string.class here, the class that I've specified here. So I'm passing an array, and then I'm also passing the type of the class here. In fact, let me just go to that method. It takes these parameters as shown here. It takes the yes, so the component type, the type of the class, it's a generic, and then the length of the array. That's what this does. And if I print that out here, it just prints out the type of the class. You can see here, it's just a string class that I've passed through. And then the get type static factory methods are similar to the example, not this example, the previous one with the StackWalker demo class with the get instance demo there. What this does is it returns a different type, essentially. So if you look at this here, I'm getting a path. I've got a file that I've created, and if I go to the files class, it's of type files, obviously, and then this get files to static factory method returns a different type. It returns a type of file store, despite being in the class files. And if you do look at the method, you'll see, I'll zoom in there again, the getFileStore, it's in a separate abstract class called getFileStore. Pardon me, it's in a separate abstract class called FileStore. So it's not in the files class. And similarly, the buffered reader does the same thing, but instead of getting a new instance, it creates a new instance. So if you go to the buffered reader, which again is in the files class, and if you go to the static factory method, it is returning a new instance of oh, that's a bit weird. Oh, of course, of buffer reader. There we go. And of course, similarly, the new type, this is the same thing, but instead of getting an instance, it'll return a new instance. So if you go to the new buffered reader static factory method, which is in the files class, by the way, as you can see here, it returns a new instance of buffered reader. Again, a different type or to what files is, or it's in a different class, let's say. And finally, really, all the other stuff weren't even that useful because, well, they are useful, but I think most of us use this, the generics, which is in the collections, things like lists, array lists, which are in the collections framework. And what this does is it returns a new vector of a given type. So, for instance, I've created this enum called complaint, and I can create a list of that type and add stuff into it, essentially. And if you want to see, it's going to print out that stuff. All these examples that I've used was sort of in the book, and I repurposed them just for me to understand. But really, from all the static factory methods I went through, I think the ones we use mostly are the ones in the Java collections framework. Nevertheless, it's important to enumerate all of them. And in summary, Joshua Bloch says, static factory methods and public constructors both have their uses, and it pays to understand their relative metrics. Often, static factory methods are preferable, so avoid the reflex to provide public constructors without first considering static factories. That was much harder than I thought. I have to admit, I thought I could sort of go through my thought process, but you know, any programmer would understand that sometimes we don't even know why we do what we do. We just type and things just happen. That's fascinating, isn't it? In any case, I hope you enjoyed the video. I hope you found it informative. I certainly, as I said in the proviso, I'm sure I've made a lot of mistakes, so please do point them out. In some sense, selfishly speaking, for my own learning, but also so that I don't mislead anyone and provide false information. I've already started working on the next item. I'm still rereading that item and starting the different examples. The second item is consider a builder when faced with many constructor parameters. I shall hopefully get to that soon, but at least for now, I hope you enjoyed this item, and I'll see you in the next one. Cheers.